In this video lecture, we will go through the mechanism of enzyme catalysis, right? And the most famous and acceptable mechanism of enzyme catalysis is your lock and key mechanism, right? And lock and key is our normal day-to-day life. We talk about lock and key, right? It's a lock and a key, and only one key can fit into a lock. Some other key will not fit into the lock. We normally know that, right? So in a while we understand why we call enzyme catalysis as a lock and key mechanism method or mechanism, right? So lock and key mechanism, we know one thing, that like other catalysts, right, enzymes which are biological catalysts are also specific in their action, which means that one particular enzyme will catalyze only one particular reaction, right? And it will not catalyze other reaction. Like we have studied in our previous lecture, that enzyme called invertase will only catalyze the hydrolysis of sugar, right, cane sugar. And say the same molecule, the same kind of molecule, maltose, right, which has the same chemical formula as your sucrose, right, it will not, the same enzyme, that is invertase, that catalyze the hydrolysis of sucrose will not catalyze the hydrolysis of maltose, right? The catalysis of maltose is hydrolyzed by another enzyme known as maltase, right? So we say that enzymes are specific in their nature, specific in their action, like let's say enzymes are specific in their action, right? Now we'll understand through this mechanism what makes enzyme specific in their action, right? What makes enzyme specific in their action, right? We know that like normal catalysts, how does a normal catalyst help in increasing the rate of reaction? What it does is it will absorb molecules onto its surface, right? And we know that on the surface of normal catalyst we have something known as active centers, right? Active centers, which are nothing but unsatisfied valencies or free valencies, unsatisfied or free valencies, right? And these free valencies will form bonds with reactants, right? This is the surface of catalyst. It has active centers which are unsatisfied valencies. So since it has unsatisfied valency, so it will quickly form bond with the reactant molecule that it will found around it, right? Similar thing we'll see in case of enzymes, which are biological catalysts. If this is this is an enzyme, right, onto its surface it has, on the surface of enzyme it has, like we have active centers here, on the surface of enzyme we have active sites, right? And these active sites consist of functional groups, right, like carboxylic group, amino group, thiol group, OH group, right? So the substrate or the reactant molecules will form bonds with these functional groups which are present in the active site of enzymes, right, through hydrogen bonding and through weak van der Waals forces of attraction, right? So these sites, these enzymes have active sites which consists of functional groups, like COOH group, OH group, right? Functional groups like COOH group, NH2 group, OH group, all these are organic groups, SH group, right? These functional groups are present in the active site of the enzymes, right? that makes it to form bonds with the substrate or the reactant molecules, right, through hydrogen bonding or through van der Waals forces of attraction, right. Same as here, the reactant molecules were getting attracted to the surface due to the presence of unsatisfied valencies, and these reactant molecules here also were forming temporary bonds with the active centers on the surface of catalyst. Here also on the surface of enzyme we have active sites which consist of these functional groups, and these functional groups will form bonds like hydrogen bonds and van der Waals force of attraction with the substrate or the reactant molecules, right. So these functional groups will form hydrogen bonds or van der Waals force of attraction with substrate molecules. Right. So these active sites, right, which contains your functional groups, right, due to which the enzyme has its activity, right. The activity of enzyme is basically due to these functional groups which are present in the active site, right. And these active sites, right, on the surface of enzyme is in the form of cavities, right. These active sites are in the form of cavities, on enzyme surface, right. Suppose this is enzyme, right. So here is the cavity. It's somewhat like this, or it's somewhat like this, right. And it contains, suppose this is the cavity, right. So it contains NH2 group, say, right, COOH group, like these, right. So what reactant molecules will do, or the substrate molecule, this substrate molecule will go and fit into this cavity, right, which is your active site. This is your active site, which is nothing but a cavity, right. So this substrate will fit into this cavity, right. This is an enzyme. The substrate S will fit into this cavity, just like a key will fit into, if this is a lock, say, right, if this is a lock, right, just like a key, right, will fit into a lock, right, if this is a lock, right, and this is a key, right. So this key will fit into this lock. This key, right, is like a substrate molecule, and this lock, the whole of this lock is like a cavity in enzyme, right. Same as key fits into the hole in the lock, same as in the similar way this substrate molecule will fit into the cavity which is in the surface of this enzyme. That is why we call this enzyme catalyst, the mechanism of this enzyme catalyst as your lock and key mechanism, right. If you notice, this is same as a lock, key fits into a lock, so a substrate molecule will fit into the cavity which is present on the surface of enzyme, right. And this cavity is such that only one particular substrate will fit into that cavity, like the other substrate, right, would not be able to fit into that cavity, and that is why enzymes are specific in their action, right. Like we said that invertase is an enzyme, right, which hydrolyzes. This invertase will hydrolyze sucrose, but not maltose, right? Because invertase, right, has this cavity, right, that can only fit sucrose. This will get fit into this invertase, right? Sucrose can get into the cavity which is on the surface of invertase, but this maltose cannot get into the cavity which is on the surface of invertase. That is why enzymes are specific in their action. Enzymes will fit only particular specific molecules or substrate onto their surface, which are the cavities on the surface of enzyme, on the surface of enzymes, right? So that is why we say that enzymes are highly specific in their nature, right? So when this substrate fits into this enzyme, right, what it forms is your enzyme substrate complex, right? It will form a enzyme substrate complex, right? Say just like an intermediate complex used to get formed here. If you remember, these are two reactants, right? These will form bonds with, it will form a complex with catalyst C, right? Same, in a similar way, this was an intermediate complex, this is an enzyme complex that gets formed when a substrate fits into the cavity on the surface of enzyme, right? So it forms enzyme substrate complex, right? This is your enzyme substrate complex which will decompose into product, and your enzyme would be regenerated, right? And it's same like any other catalyst that gets regenerated, at the end of the reaction. So enzymes are also regenerated at the end of the reaction, right? Because the enzyme substrate that gets formed is unstable, right? And it will decompose to give you product and regenerating your enzyme, right? And these enzyme and your substrate should be in specific orientation, right? Only when this substrate and this enzyme is in that favorable orientation that this substrate can fit into this enzyme, only then this enzyme substrate complex will get formed, which will later dissociate into product and this into the enzyme, hence regenerating the enzyme, right? So this is your lock and key mechanism, right, of mechanism of enzyme catalysis, right? And this product, right, this product will leave the enzyme surface. This product will leave the enzyme surface, same as here. This product, what it used to do when this intermediate complex was dissociated into products and catalyst, this will leave the enzyme surface because this will leave the catalyst surface because this product does not have any affinity for the catalyst surface. Same here, product does not have any affinity for the enzyme surface, so this product will leave the surface of enzyme, right, since it does not have affinity for product, right? So this product will leave the enzyme surface, creating a room for the fresh substrate molecules, right? So this is how your enzyme catalysis works, right? Just remember one thing, let's just brief quickly. You have enzyme, right? On the surface of enzyme we have active sites. Those active sites contain active functional groups or reactive functional groups, right, that will react with the substrate or the reactant molecules through hydrogen bonds or van der Waals forces of attraction, right? So the substrate molecule, when in proper orientation, will fit into the cavity, right, which is nothing but an active site, right, forming hydrogen bonds or van der Waals forces of attraction with the functional groups inside the cavity, right? So they form the substrate will form enzyme substrate complex when in proper orientation, right? and this enzyme substrate complex being unstable will dissociate into product and regenerating the enzyme. Since this product does not have any affinity for the enzyme surface, so it will leave the enzyme surface, right, creating room for fresh substrate to get fit into this enzyme cavity, and hence the reaction will continue with this enzyme, right. And this is same as lock and key mechanism. Just as a key fits into the hole of a lock, same as this one particular substrate molecule, since only one particular key will fit into the hole of this lock, so only one particular substrate will fit into the cavity which is on the surface of this catalyst, right. So that is why we say that enzymes are specific in nature, because only one particular substrate will fit into the cavity which is on the surface of the enzyme, right. So this is your mechanism of enzyme catalysis, which is your lock and key mechanism. I hope all this is clear to you. Thanks.